All right, so this is our last lesson. So now we're going to take a look at the measures, how to find the measures of a chord, tangent segments, and secant segments. Okay. So remember, we're going to talk. So we're going to briefly remind us what similar triangles are. Okay. So two polygons are similar if A, all pairs of corresponding angles are congruent, and B, ratios of the lengths of all pairs of corresponding sides are equal. Okay. Now, corresponding sides of similar triangles are proportional to each other. So, proportional. And two triangles are similar if two angles of one triangle are congruent to two angles of the other. Okay. All right, so now let's take a look at this, our first theorem here. So if two chords intersect within a circle, the product of the measures of the segments of one chord equals the product of the measures of the segments of the other. Okay. So based on this diagram, the product of AE and EB, so AE times EB, is equal to the product of DE times the product of EC. Okay. So AE times EB is equal to DE times EC. Okay. So let's take a look at some vocab words, some terminology. So FH is a chord of the circle because its endpoints are points on the circle. Now EF is called an external segment. Of the secant because it is a line segment whose endpoints are an external point, because E is not an external point, is a point outside the circle, and a point on the circle nearer to the external point than any other point of the chord. So since EF is closer to E than H, then EF is our external segment here. Okay, so this is our chord. Did not spell that correctly. Chord. Oh my gosh. Okay, that's a chord. All right. And now EH, this whole thing, is called a secant segment. Secant segment because it is a line segment whose endpoints are an external point and a point on the circle farther from the external point. Okay, so this is our secant segment. Okay. All right. Onward we go. So let's talk about yet another theorem. All right, so if two secants intersect outside a circle, so we have two secants here that intersect outside of the circle at point A, then the product of the measures of one secant segment and its external segment is equal to the product of the measures of the other secant segment and its external segment. Okay, so this is the whole. This is the external. And this is the whole. And this is the external. Okay. Now, the upper secant segment is AE. And the upper external is AD. The lower secant segment is AC. And the lower external segment is AB. Okay, so its equation is AE, which is our whole, times AD, which is our external, is equal to AC, which is the whole, times AB, which is the external. Okay? So we have the whole times the external equal to the whole times the other external. Okay? So let's do an example. So if AC is 10, AB is 4, AE is 12, we want to find the length of AD. Okay, so I'm going to redraw this diagram down here. So A, D, E, C, B. Okay, so AC is 10. So this whole thing is 10. AB is 4. AE is 12. We want to find the length of AD. Okay. So we're using this formula right here. So we're doing AE, our whole, times our external, which is AD, is equal to AC, our whole again, times AB, which is our external. Okay. So ACE, now we're just going to plug these values in for here. So AC is 10, AB is 4, A is 12, and AD is X. So that's what we're trying to find. Okay. Now we just solve for X. So 12 times X is 12X. And 4 times 40 is 4. 4 times 10 is 40. So 40 divided by 12. X is, you're going to get a repeating number. So 3.3 repeating. Okay. So AD is equal to 3.3 repeating. Okay. All right, so let's do another example. So if AB is equal to 9, BC is equal to 11, and AD is equal to 10, we want to find the length of AE. Okay, so we are going to draw another diagram. So AE, D, C, and B. Okay, so AB is 9, BC is 11, and AD is 10. We are looking to find the length of AE, which is this whole segment. Okay, so we're still going to use what we have up here. So AE times AD is equal to AC times AB. Okay, so let's plug them in. AC is X. AD is 10. AC, now be careful, AC is this whole thing. So it's 9 plus 11, which is 20. And now AB is 9. So 9 goes here. Okay? And now we just solve for X. So 10 times X is 10X. 20 times 9 is 180. So divide by 10. So X is equal to 18. So the length of AE is 18. All right, let's go down to the next one. All right, last page. Oh, woo, yay. All right, so if a tangent and a secant are drawn to a circle from an external point, then we have the square of the measure of the tangent segment is equal to the product of the measures of the secant segment and its external segment. Okay, so let's go through. Let's name the tangent segment, secant segment, and external segment. Okay, so the tangent segment is PA. The secant segment is PC. The external segment is PB. Okay, so this is my tangent. This is my secant. And this is my external. Okay, so our equation for this is tangent squared. I'm going to use the first of all, I'm going to write this here. So we have tangent squared is equal to the product of the whole times the exterior. Okay, but we're going to use the segments in this diagram. So PA segment PA squared is equal to PC times PB. Okay, so our tangent, our secant segment, and our external segment. Okay. All right, so let's do a couple of examples. So we're going to use this diagram. So let's do number 1. So if AC is equal to 12 and AB is equal to 3, then we need to find AF. Okay, so we need to find this. AB is 3, and this whole thing is 12. Okay, so remember, our tangent squared is equal to the whole times the exterior segment. Okay, so our tangent, length of our tangent segment is x, so this is x squared. Our whole is 12 times our exterior segment, which is 3. So x squared is equal to 36. Now we're just taking the square root, so x is equal to 6. So the length of AF is 6. Okay. All right, last one. All right, so I'm going to redraw this diagram here. So we have A, F, B, C. Okay, so remember, ratio, we just add an x on it. Okay, so if the ratio of AC to AB is 4:1 and AF is 12, then we want to find AB. So AB is what we want to find. Now, the ratio of AC to AB is 4:1. So this is 4x, this is 1x, and AF is 12. Okay, so we're just going to plug it into our tangent squared is equal to the whole times the exterior. Okay, so our tangent is 12. Our whole is 4x. Our exterior is x. Okay. Again, simplify and find x. So 12 squared is 144. 4x times x is 4x squared. Now to solve for x, first thing I'm going to do is divide by 4. So 144 divided by 4 is 36 is equal to x squared. Then we just take the square root, so 6 is equal to x. So the length of AB is equal to 6. Okay.